that every block of metal has tons of microscopic voids inside it? And that these microscopic voids actually play a crucial role in failure. When a metal is stretched or loaded, these voids start to grow and link together until the metal fails. If we look at a copper bar being pulled in tension, we see that it behaves the same. In the center region, it necks down until eventually it fails. Now you might ask, what about those voids? How do we know they're the reason for failure? Well, one way we know is by looking closely at the fractured surface. The surface has many dimples, which is a sign that voids have grown and linked together. Now if we zoomed in on a chunk of metal, it might look like this. If I zoomed in the same amount on a human hair, it would look like this. But if I wanted to analyze this chunk of metal, it would be quite difficult because there are many voids and they are all scattered randomly. In my work, I look at one void at a time, and using a computational model, I look at how it responds to many different loads. I am then able to stitch together the responses of individual voids to understand how the metal will behave on a much larger scale. The simulation you see here is another tension test, where this notched bar is pulled until it fails. One of the very useful things about computational simulations is that we are able to look inside the material to see how the failure process occurs. You can see here that failure occurs as a crack that starts at the center of the member and propagates outward. So, by using a bunch of models of microscopic voids, I'm able to make predictions about how and when larger elements will fail. The truly amazing thing is that these predictions actually correspond to experiments. I'm able to show that damage starts to occur in the center of this element and leads to a crack, which is the same as seen in experiments. The use of computational models such as mine, when combined with simple experiments, will help improve our ability to predict cracks and ultimately help to avoid the failure of our structures. So, as we move into the future,